Hi YouTube, Tim Unkert here. In this video, we're going to find the recursive definition for a geometric sequence. Okay, so we've got a geometric sequence here, 4, 16, 64, 256. Now, the recursive definition is going to have two parts. It's going to have the initial condition, we'll call that a sub 1, and that's going to be the first term. So that's going to be 4 in this case. And then to find the nth term, what we're going to do is we're going to say a sub n equals the previous term, we'll call that a sub n minus 1 times the common ratio. The common ratio is what you multiply a term by to get the next term. So to figure out the common ratio r, so it's going to be times r. We'll figure out the number and then put that in here in a moment. So we're going to take any term, so we'll take, let's say 16. Just don't take the first term. And then you're going to divide by the term before it. So if I pick the second term, 16, I'd divide by 4. So 16 divided by 4 is 4. So my common ratio is 4. So instead of r here, we're going to have 4. And this is for when n is greater than 1. Okay, so if you're trying to find the first term, you know the first term is 4. A sub 1 is 4. But if you're trying to find the second, third, fourth, and so on, and you're using the recursive definition, you'd use this right here, along with this as a starting point for the first term. Okay, let's keep going and try some more of these so we can make sure we've got it. All right. So problem 2, write the recursive definition of the following geometric sequence. So we'll start with the initial condition, the first term, a sub 1, that's equal to negative 2. And then a sub n, the nth term, is going to equal a sub n minus 1 times our common ratio. So we've got to figure out what our common ratio is. So our common ratio r, we could take, let's say the fourth term, 16. So we pick the fourth term, we divide by the third term, so divide by negative 8, the term before it. 16 divided by negative 8 is negative 2, so our common ratio is negative 2. And this is for when n is greater than 1. So there we go. That's our recursive definition for this one. Let's try a few more, or a couple more. I think I have 2 more problems here. Okay, so problem 3, write the recursive definition of the following geometric sequence. We have 1, we then have 5, 25, and 125. So our initial condition, a sub 1, equals the first term, 1. And then we'll say a sub n equals a sub n minus 1 times our common ratio r. So r is going to equal, let's take the third term here. We can take the third term and divide by the second term. So 25 divided by 5. So r would equal 5. So I say times 5 for when n is greater than 1. Okay, so that's our recursive definition for this one. All right, let's try one more. Write the recursive definition of the following geometric sequence. We have 10, negative 30, 90, negative 270. So we'll start with the initial condition. A sub 1 equals the first term, 10. And then a sub n equals a sub n minus 1 times our common ratio. So our common ratio r is going to equal negative 30 if I take the second term, divided by the first term, the term before it. So negative 30 divided by 10, which is negative 3. So times negative 3 for when n is greater than 1. So this is our recursive definition for our geometric sequence here. Hopefully you found this video helpful. If you did, please like and subscribe.